Hello guys, my name is Engineer Holiday. Welcome to chapter 2 of physics, which is vectors and scalars. Those of you that have been watching my videos, thank you for watching. And those of you that are watching for the first time, please, as you enjoy the video, please subscribe. We are discussing vectors and scalars. First of all, we need to understand what is vector and what is scalar. This is a common topic in physics. Now, vector is that which has magnitude and direction. So that means that a vector is a quantity. There are quantities that have magnitude and a specific direction. Then scalars are quantities that have just magnitude only with no direction. And in physics, we understand that the vectors examples are few compared to scalars example. Just like people that don't have directions are more than people that have direction. The same thing with physics. Those quantities with directions are few compared to a quantity without direction. So now we start by giving examples of vectors and scalars. Now, what are the examples of vectors? You should understand that examples of vectors are extension, weights. All forces are vector. All forces are vector. Most fields are vector except scalar field like temperature field, pressure field. Most fields like magnetic field, electric field, gravitational field are vectors. Then we have forces like upthrust, viscous force, reactional force, weight. They are all vector. Now we also have acceleration, displacement. We have angular displacements, angular velocity, angular acceleration, moment, torque, momentum is our current density. For in the temperature gradient, I know temperature is a scalar, but temperature gradient is a vector. We have pressure gradient, we have density gradient. These are vector. We have current density, which I've mentioned before. We have velocity. Velocity is a vector, while speed is a scalar. Angular velocity is a vector, but angular speed is a scalar. We have current is a scalar, but current density is a vector. Though we have several examples that are so confusing. For example, force ratio is a vector, but surface tension is a scalar. If you check their units, you see that they have the same unit. So these are very interesting parts that we are going to be looking at. So in the exam, what they will ask you, they will not, because most textbooks will just tell you vector is that which has magnitude and direction, then displacement, acceleration, velocity, etc., etc., etc. That etc. is where most questions are coming out for these professional exams that we write. So that is why we try to ensure we explain a lot of examples about vectors and examples of scalars. Although there are arguments and which is confirmed that we have another quantity that we call a tensor quantity. A tensor quantity are quantity that has magnitude and direction, and the direction are tends towards a coordinate and orientation. For example, stress. When a building is under stress, it has a magnitude, it has a direction in a specific coordinate. We have moment of inertia, we have conductivity, we have strain. These are tensor quantity. So we have other quantity that are not under scalar, not under vector, but they are under tensor. I've mentioned strain, stress, conductivity, moment of inertia, and so forth and so on. Also, when we talk about impedance, impedance is a complex vector because impedance is written in terms of impedance. This is it. Impedance. Impedance is a vector quantity. If you want to write impedance, I mentioned extension before. Let me clear this. We can write it as Z equal to R plus XJ in complex number. So Z is an impedance and is a vector quantity. Resistance and reactance are scalar. These are confusing part that people have to know. Now, look at this now. Weight, viscous force, reaction, angular acceleration, angular velocity, velocity, acceleration, displacement, torque, moment, momentum, density gradient are mentioned, force gradient, pressure gradient, temperature gradient, magnetic field induction or flux density as given, electric field intensity, phase velocity, gravitational field, and all forces are what vectors. Most field are scalar, most vector field are scalar. Then for a vector, but most scalar field are what? Scalar. Example of scalar field is pressure field, temperature field. Then we have force gradient, charge, power, density. All energies are scalar. Then work, I did not put work here, probably can add work to it. Power, volume, area, altitude, height, depth, thickness, decay constant, resistance, reactance, resistivity, then current. We have a charge, we have a energy of just what all potentials are scalars. Maybe gravitational potential, electric potential. I didn't put gravitational potential here, but I think that can serve us what all the potentials that we have, then classify them. EMF. Don't forget, electromagnetism is a tensor quantity, not a scalar. Electromagnetic quantities are tensor quantity. Now, listen and listen so good. Now, when we talk about scalars, we say those that have magnitude or no direction. If you check the example listed on the board, you see that there are more scalars than vector quantity. We have temperature, we have Young modulus, we have pressure, we have density, we have mass, we have time, we have work, we have volume, we have area, we have temperature, we have current, we have power, we have EMF, we have pressure field, we have temperature field, we have speed, we have angular speed, we have resistance, we have reactance, we have many of them like that. Then we have flux, magnetic flux, electric flux, and all that. These are resistivity, length, force ratio, efficiency. These are what? Examples of scalar. Now let's go into questions since I've enlightened us so that we can round up this definition and example section of chapter 2. Now, the question says, which of the following, number 1 question, 1980, number 11, which of the following physical quantity is not a vector quantity? So I believe you can write it down, and as you are listening to this class, you will also jot down to learn and also what write down the question to what follow up. You can even be answering the question for one side. A, velocity, B, work, C, force, D, electric field intensity. Which of the following physical quantity is not a vector? Velocity, A, is a vector. Work is a scalar. Force is a scalar vector. D, electric field intensity is a vector. So the answer is work, option B. Number 2, the examples of scalars. Scalar quantity is dash. A, weight. A, velocity. B, weight. C, electric charge. D, acceleration due to gravity. Acceleration due to gravity is a vector quantity. Any kind of acceleration, angular acceleration, linear acceleration, acceleration due to gravity, they are all scalar. So this question is what? Option B. Option C rather, because A say velocity, B say weight, C say the electric charge, D say acceleration to gravity. So 1981, number 15, the answer is C. Number 3, which of these following is not a vector quantity? A says altitude, B say weight, D say, C says displacement, and D says acceleration. So which of the following is not a vector quantity? Altitude is not a vector quantity. As you can see, it's on the board. Altitude is not a vector quantity. Now, that is option A. Number 4, which of the following quantity are scalars? Roman figure 1 is electric potential. Roman figure 2, torque. Roman figure 3, momentum. Roman figure 4, kinetic energy. Which of the following quantity are scalar? So Roman figure 1, electric potential. All potentials are scalar. I've talked about that before. So Roman figure 1 is correct. 2, torque is not correct, vector. 3, momentum is not correct, and 4, kinetic energy correct. So it should be 1 and 4. Option A say 1, 2 and 3 only. B, 1 and 3 only. C, 2, 3 3 and 4 only. D, 1 and 4 only. That should be the correct answer. That is 1988, number 5. Now, number 5 question says, which of the following is a set of vector? A, force, mass, and momentum. Wrong. Mass makes that option very wrong. Option B says acceleration, velocity, and moment. All of them are vector. C says what? Mass, velocity, and density. Mass is a scalar, density, weight is a vector, density is a scalar. So that one is wrong. D says mass, volume, and density. All of them are scalar. Option D. That is 1989, number 1. That should be answer is what? B. Acceleration, velocity, and moment. Number 6. Which of the following is a vector? A says electric charge. B, electric field. C, electric potential difference. D, electric car capacitance. All others are what? Are scalar except electric field. Most field are vector. Most vector field are vector. Example is gravitational field, electric field, and what? Magnetic field. But every other scalar field, like temperature field, pressure field, are scalar. So that is the answer. This option B, 1990, number 36. Number 7, which of these following consists entirely of vector quantity? A, velocity, magnetic flux, and reaction. Option A is wrong because of magnetic flux. Magnetic flux is a scalar quantity, not a vector. So option A that says what? Velocity, magnetic flux, and reaction. Reaction is a force. So that one, magnetic flux, make it wrong. They say which of the following consists entirely of vector quantity? B says tension, magnetic flux, and mass. No, that one is also wrong. Tension is only correct vector. The others are what? Scalar. C says displacement, impulse, and power. In displacement, impulse are vector, while power are scalar, or power is a scalar rather. Then D say work, pressure, and moment. That one also not correct. This 2001, number 9. I think none of the options is correct. So I will say that no answer is correct for 2001 JAM question number 9. Let's go to number 8. Now they say the pair of what? I think we are going to continue from here. We'll stop at number 8. Please make sure you watch part 2 of this video so that we can, continue, helping ourselves to make sure we grow in physics. You can actually understand physics by what? Watching my video. Those of you that are writing exams, just follow us. We make sure we cover the syllabus on this particular channel. Thank you. God bless you.